Hey guys, it's Mr. Rowan here. We're going to talk today about congruent and similar solids. So you hopefully remember these terms from when we were talking about two-dimensional shapes, namely triangles. But just to refresh your memory, shapes that are similar, they have the same shape, they have the same proportions and dimensions, but they're not necessarily the same size. Whereas congruent shapes, all of their sides and angles are going to be the same. So let's take a look at how this compares in a three-dimensional shape. Um, so we have 8 over 4. So you recall we're using the same colors to mark the corresponding parts. And then 8 over 4 equals 10 over 5 equals 6 over 3. And if this proportion is correct, then we know that our shapes are similar. 2, 2, and 2. So yes, correct, they are similar. We win. Yay. Okay. And so then what we'll do, oops, yep, let's erase that. Okay, so what we want to do now is we want to compare the ratios of our sides. So the sides, if we make it into a simplified fraction, it's 2 to 1. So for every 2 units in the shape on the left, there's 1 unit in the shape on the right. Okay, so let's take a look at how this could compare with the cylinder. So they're sort of tricking us a little bit here, because they're showing us that the diameter here is 9. So the radius is actually going to be half of that. It's going to be 4.5, right? And then 4.5 over 18. And then we'll see, does that equal the same thing as 10 over 40? And so if you do the calculations, you should get 0.25 equals 0.25. So these shapes are also going to be similar. So we win again. So we're going to skip ahead a little bit and look at the general theorem for this. So if our scale factor is a to b, so like 2 to 1 or 4 to 1 like it was before, then the ratio of the areas is going to be a squared to b squared, and the ratio of the volumes is a cubed to b cubed. So let's take a look at an example here. So we have two different balloons that we use to decorate the party, and they're spheres when you blow them up. So the bigger one has a radius of 18 inches, and the smaller has a radius of 8 inches. So let's take a look at the scale factor for our radii. So for the scale factor, all we have to do is just divide our our measurements. So 18 to 8 when we write it as a ratio like that. And that's 9 to 4 when we simplify it. Okay. Now we want the ratio of the surface areas of the balloon. So that's a squared to 4 squared. That's 81 to 16. And then the ratio of the volumes is 9 cubed. So let's see, that's 810 minus 81 is 719 to 64, I think. Oh, 729, my bad. Yeah, 729 to 64. Right. Take a look at an example problem. So for this one, two rectangular prisms are similar and they have a scale factor of 1 to 4. And so we want to find the surface area and volume of B, given that the surface area of A is 28 and the volume is 8. Okay, so when we're comparing the surface area, it's 1 squared over 4 squared equals 28 over B. Because remember, we always square the scale factor. So 1 over 16 equals 28 over B. We'll do a little cross multiplication. So 16 times 28, that's 448 equals B. Okay. And now we'll do the same thing for A. You know that A is 8. So we'll take our scale factor again and we'll just cube it. So volume is cubed, so it's 1 cubed over 4 cubed equals 1 over B cubed. That's 1 over 64. Because that's 4 cubed equals 8 over B cubed. So B equals 8 times 64, so that's 512. Okay?